Hi, everybody. It's Mr. Glover here, just getting ready to do our next set of notes. So today we're going to compare two different versions of the quadratic formula. We're going to compare the standard form to the vertex form. We can talk a bit about why one might be preferred to the other. And then we're going to learn how to convert between the two forms. So first we'll start by just defining them. Standard form is when you have a quadratic that has it's been expanded out. So it'll be written in the form of ax squared plus bx plus c, where a and b and c are all real numbers and a is not zero. If a is not zero, this isn't a quadratic. Or if a is zero, this isn't a quadratic. Compare this to vertex form. A times x minus b squared plus c. And again, a, b, and c are real numbers. I guess this should be B and this should be C. So let's talk about why you might want one form versus the other. In standard form, it's easier to factor, and by factoring, you can find your x-intercepts or your zeros. It's also convenient for using the quadratic formula to find your zeros. C, your constant in standard form is always going to be your y-intercept, but it's not in vertex form. So those are really the two major things that are going to be benefits to the standard form, finding your zeros and finding your y-intercepts. In vertex form, we can clearly see the stretch vertically, the translation horizontally, and the translation vertically. And we can use B and C to find our vertex. So vertex form is convenient for finding the vertex. I find it easier for sketching my graph, and it tells you a lot of information right off the hop. It's also easier to transform this version because you can easily put it B spaces to the right or C spaces up, depending on what you want. It's a little bit more work with standard form. So let's talk about converting between the two forms. Converting from vertex form to standard form is easy. All we have to do is expand the brackets, and we're going to have to simplify. So if we want to convert from this form to standard form, we've got to take these brackets and we've got to FOIL them out. So it's going to be minus 2 times x minus 5 times x minus 5, which will be x squared minus 10x plus 25, and then plus 1. This is just x minus 5 FOILed out. We can then multiply minus 2 into our brackets. So it will become minus 2x squared plus 20x minus 50 plus 1. And then we just simplify, join any like terms. So minus 2x squared plus 20x minus 49. And now we've got it in standard form. Or actually, I think your book might call this general form or something. It's vertex form and standard form is what I always call them. So now we know right off the bat, y-intercept of minus 49, and we can plug this into our quadratic formula to find our zeros. All right, this one is another one. Would be an on your own, but we'll go through it together. So we've got to expand our brackets out first. So this is 3 times x plus 1 squared. It's going to be x squared plus 2x plus 1 minus 7. We then can simplify or multiply the 3 into our brackets. So 3x squared plus 6x plus 3 minus 7. And then we just combine like terms. There's only one x squared term, that's 3x squared. There's only one x term, that's plus 6x. And then plus 3 minus 7 is minus 4. So we now know that this equation or this function has a y-intercept of minus 4, and we could go ahead and factor it to find our zeros. To convert from standard form to vertex form, however, we're going to need to do a little bit more work. We are going to have to complete the square. but we're going to do it a little bit differently than we did before because this is a function, not an equation. But it's essentially the same process, the same steps, all right? So I'm going to move 51 over first by subtracting it. Y minus 51 equals 4x squared minus 32x. Okay, and now I want to try to complete the square on this right-hand side. Before I do it, I'm going to get rid of 4 because I can't complete the square unless my leading coefficient's 1. So I'm just going to factor it out. I'm not going to divide by 4. 51 does not divide cleanly by 4, and it's going to make a fraction. I don't want that. So y minus 51 equals 4 times x squared minus 8x. Okay. And now this is the point where we're going to complete the square. We need to take b, divide it by 2, and square it. So we can write that off to the side somewhere. B over 2 all squared, it equals 8 over 2 squared. So it's going to be 16. But instead of adding 1 to one side and 1 to the other side, we're going to kind of use a trick. We're going to add it and then subtract it immediately. We're allowed to do it because if you add something and then subtract it, it's like adding nothing. It's equivalent to adding it to both sides, but I only want it on one side. So I'm going to go y minus 51 equals 4 times x squared minus 8x plus 16 minus 16. Okay, and then this is essentially 0. Why I did this is because I have a perfectly completed square now. Just a second here. This is a perfect square trinomial. I'm going to move the 16 out. So y minus 51 equals 4 times x squared minus 8x plus 16. And then 4 times negative 16 is minus 64. Now I've got my perfect square trinomial sandwiched in these brackets. I can simply turn it into x minus 4 times x minus 4. So y minus 51 equals 4 times x minus 4 squared minus 64. And this is just the perfect square trinomial attached to this. And the last step is to move 51 back. So y equals 4 times x minus 4 all squared minus 64 plus 51. I'm kind of running out of room, so I'll put it over here. So your final answer is that y equals 4 times x minus 4 all squared minus 13. Now that we have it written this way, we know that a is 4, b is minus 4, and c is minus 13. And we're done. One thing I kind of want to point out, the reason why I think the textbook uses different letters than a, b, and c for this variable, and this variable, is so you don't get confused with a, b, and c in the quadratic formula. You cannot plug these numbers into the quadratic formula. It's not going to get you your zeros. So just keep in mind, that's a small difference. I've kind of gotten lazy and just called them a, b, and c, but I think the book calls them p, q, and k or something like that. Okay, let's do another one of these. So same process. We're going to move the 2 to the other side first. Subtract 2. So y minus 2 equals negative 1/2 x squared plus 5x. All right. And now I'm going to try to make my x squared term, I'm going to get rid of its coefficient. So I'm going to divide out my minus 1/2. Y minus 2 is still on the left, negative 1/2, but then the rest of the right-hand side goes in brackets. Removing the 1/2 from x squared just leaves it as x squared. But when I divide 5 by negative 1/2, it becomes negative 10x. It's just a finicky little difference. When you multiply the minus 1/2 back in, it becomes plus 5x again, but for now it has to be minus 10x. We're going to complete our square. So we're going to do b over 2 all squared. That's going to equal 10 over 2 squared, which is 5 squared, which is 25. All right. We're now going to do our trick where we add 25 and subtract 25. So y minus 2 equals negative 1/2 times x squared minus 10x plus 25 minus 25. I'm going to move this 25 out. So y minus 2 equals negative 1/2 times x squared minus 10x plus 25. And then minus 25 times negative 1/2 is going to be plus 25 over 2. I don't like having fractions, but we're kind of stuck with them right now. Okay. We can now complete the square. This is a perfect square trinomial. We can turn it into x minus 5 all squared. So we're going to do that. Y minus 2 equals negative 1/2 times x minus 5 squared plus 25 over 2. And then we have to move the 2 back over. Y equals negative 1/2 times x minus 5 all squared plus 25 over 2. And then plus 2. We've got to join 25 over 2 with 2. It's going to be a little bit tricky. So minus 1/2 times x minus 5 all squared plus 25 over 2. But instead of writing it as 2, I'm going to write it as plus 4 over 2, because now it's got a common denominator and we can join it with the other fraction. And lo and behold, minus 1/2 x minus 5 all squared plus 29 over 2. And we are done. So when you're solving for from general to vertex, move the constant over, remove your leading coefficient by factoring it out, complete the square, but you have to add and subtract that extra term, remove the extra term, turn your perfect square trinomial into a perfect square, and then you have to do a bit of algebra to move everything back to the one side. That's basically it. If you're given a choice, I would almost always choose to go from vertex to general. But if you have to go from general to vertex, this is how you do it. So one more question for today. Determine whether the following functions are the same. So we've got a choice. We can take this form and try to convert it into this form, or we can just expand the vertex form and see if it looks like the general form. I'm going to expand vertex form because it's less work and it's more straightforward and I'm less likely to make a mistake. All right, so I'm going to take this version right here. Oh, yeah, we can leave it like that. I'm going to take this, we're going to expand and convert to standard form. So we take the equation, y equals minus 2 times x plus 4 all squared plus 1. We need to expand our brackets. So this equals negative 2 times x squared plus 8x plus 16 plus 1. And this just comes from FOIL, remember. It's like x plus 4 times x plus 4. We can then multiply our quadratic by minus 2. So it'll become negative 2x squared minus 16x minus 32 plus 1. And last but not least, we join all our terms together. Minus 2x squared minus 16x and minus 32 plus 1 is minus 31. So this is what the equation looks like in general form. Does it match this equation? We've got y equals minus 2x. That part's good. But minus 16x is not the same as minus 2x. These are different. And minus 31 is not the same as plus 1. So because of this, the two equations or two functions are not the same. Another option you would have for this question would be to graph both functions and see if the graphs coincide with one another. Um, in a normal setting, I would probably put this on a portion of the test where you don't have a graphing calculator, so you would have to know how to do it by hand. But right now, that is an option. This is how I would prefer you to do it, though, because the whole point of this is to build those skills from converting one form to another form. So I've got some questions for you to try. Page 315. I want you to do 2, 3 ACE, and then 4 to 6. That's going to be your homework for today. I think I'll end the chat now, and I will see you all in a couple days. So have a great rest of the day. Have a good weekend, everyone, and we'll see you all on Monday. Bye for now.